All right, on this warm-up, we're focusing on the distributive property. So we have 3 times the quantity, 2x minus 5. So we're going to distribute that 3 first to the 2x. 3 times 2x is 6x. 3 times negative 5 is negative 15. That's all I'm looking for there. Now we're distributing the 2x. We have 2x times the quantity, negative 5x plus 7. 2x times negative 5x, well, we can think of 2 times negative 5, that's negative 10. X times x, that's x squared. 2x times positive 7 is positive 14x. The last one, we have negative 4 times the quantity negative x squared minus 3 over 2x plus 1. So we're distributing that negative 4 to the negative x squared. A negative times a negative is a positive. So that's going to be positive 4x squared. On this next part, we're multiplying negative 4 times a negative 3 halves x. So that's going to be a positive because a negative times a negative is a positive. 4 times 3 in the numerator, that's 12 over 2x. And negative 4 times positive 1 is negative 4. So I'm going to rewrite that because this 12 over 2 can be rewritten as 6 because 12 divided by 2 is 6, x minus 4. And that is the warm-up for today. Are there any questions on that? All right, so we're recording again. So we're going to distribute the 2x, or the 3 to the 2x minus 5. So 3 times 2x, that's 6x. The 3 times the negative 5 is negative 15. So notice that if we distribute it here, it's going to be the same as the result inside the box here. And we're distributing the 2x to the negative 5x plus 7. 2x times negative 5x is negative 10x squared. And 2x times positive 7 is 14x. Negative 4 times negative x squared is positive 4x squared. Negative 4 times negative 3 halves x. Negative times a negative is a positive. 4 times 3 is 12, divided by 2 is 6x. That's the same one we did from the warm-up. Now, all of these are. And the negative 4 times the positive 1 is negative 4. So this really is the warm-up continued, just looking at it a different way. Now here, what I'm drawing your attention to is the fact that if this is what you're given originally, we can factor out a negative 3 from this by saying, all right, negative 3 times what is equal to 6x? And the answer is negative 2x. Negative 3 times what, negative 3 times what will give us 12? And the answer is negative 4. So this is factoring. Notice that factoring is the reverse of distributing. So if we're given this and we want to factor out a negative 3, we could use this box method. So on this one, we're asking 5 times what is 45x? 9x is our answer. 5 times what is negative 10? And negative 2 is our answer. So we could write here 45x minus 10 is equal to 5 times the quantity 9x minus 2. So that's really what it is we're getting at here. This is what we're really wanting, and this is just the method we're using to get there. Negative 2 times negative 7x squared will give us 14x squared. negative 2 times 9x will give us negative 18x. And negative 2 times negative 6.5 will give us 13. Now, we don't often get a decimal, but it's possible. There are situations where we do that. Questions on that one? All right, now this is factoring quadratics, and we're leading up to it really here. So what we ask ourselves is x times what is x squared? Well, x times x is x squared. X times what is negative 5x? And the answer is negative 5. And what we can notice is that 3 times x is 3x, and negative 5 times 3 is negative 15. So down below, the quantity x plus 3 times the quantity x minus 5 is equal to x squared minus 2x by combining these two, minus 15 right here. On to the next one. X times what is x squared? X. X times what is negative 6x? Negative 6. And we can see that x times negative 4 is negative 4x. And negative 6 times negative 4 is positive 24. So we can write this equation as the quantity x minus 6 times the quantity x minus 4 is equal to x squared. And then we're going to combine the negative 6x and the negative 4x for negative 10x plus 24. Questions? No questions there. All right, I'm going to pause the recording here. All right, I missed a little bit of the recording there, but we're going to get going from here. So, factoring these two quadratics. The first thing I notice is that my coefficient in front of x squared is not 1. And so I look at the other values here, and they're not divisible by 2. If they were, we would do something different. And I'll talk about what we would do on this one. But they're not. So all I can do is say, all right, well, I'm going to factor it into 2 sets of parentheses. Because this is 2x squared, I know that I need to have a 2x and an x, because 2x times x is 2x squared. Now, because this is positive, I have to look here. And because that's negative, so when our constant is positive and our x term is negative, that means that these both need to be subtraction. Okay, now I ask myself, what times what could give me positive 12? Well, it could be 6 and 2. So I can think, all right, I'm going to try, let's see, a 6 here and a 2 there. Well, that'll give me 2x squared minus 4x minus 6x. That would be minus 10x, but that doesn't work. Notice what I'm doing is I'm foiling. I'm using FOIL here, but this doesn't work. So what if I do 2 and 6 here? 2x times negative 6 is negative 12x. Negative 2 times x is negative 2x. Negative 12x combined with negative 2x would be negative 14x, and that doesn't work either. So the 2 and the 6 don't work. So what else multiplies together to give me positive 12? 3 and 4. So let's see, we'll put a 3 there and a 4 there, and let's try 2x times negative 4, that's negative 8. Negative 3 times x, that's negative 3x. So negative 8x, I think I left that x off there before, sorry. Negative 8x minus 3x is negative 11x. So that one works. Be careful, if you switched these, it wouldn't work. So it's a little bit of trial and error, but you can start to see it as you do more of these, you'll start to see them a little more clearly. The next one, I notice that this 3 can be factored out of each of those terms. So that's going to be the first thing I do. 3 times the quantity. So I divide this by 3, and I'll get x squared. Then I divide this by 3, and I get 6x. And I divide this by 3, and I get 5. So my first step here was factoring out the 3 because each of these values are divisible by 3. So this expression is equal to that expression. Now I can factor this quadratic in here. So I have that 3 outside, and I'm going to factor the quadratic inside the parentheses. X squared tells me that I can have x times x. This is positive, and this is positive, so these have to be positive. Multiplied together to give me 5. Ooh, that's just 5 and 1. And since these are both x, it doesn't matter where I put it. 1 and 5, or switch these. Because these are x's, you can switch them. This being a 2 was why it was important that you had them in the right place. All right. Questions on this one? I love answering questions. Okay. Now, we're going to factor these. These are called difference of squares quadratics. And here is why they are called difference of squares. Difference means subtract. Squares, because x is squared. Your dog got out and you had to chase her through the neighborhood. It's okay. I didn't even know, Anthony. You got her back, though? I hope so. Okay, good, good. She's safe. All right. So difference, because these are all subtract. And squares, because we have x squared. And 9 is a square number. X squared and 25 is a square number. X squared and 81 is a square number. So a square number, what I mean by that is that there is some number that when you square it will equal that. 3 squared equals 9. 5 squared equals 25. 9 squared equals 81. So that's why those are called square numbers. So when we factor a difference of squares, it's pretty nice. We just always have, well, not always, but if this is x squared, we just have x and x. And then we have a positive and a negative, always. And then we do the square root of 9 is 3. For the next one, x times x is x squared. It's always positive and negative. It can be negative and positive, doesn't make any difference. Square root of 25 is 5. On the third one here, we have x and x. Positive and negative. Square root of 81 is 9. Now, I've done 3 of these, and on the middle one here, I'm going to show you something. If we did FOIL, x times x would be x squared. X times 5 would be 5x. Negative 5 times x would be negative 5x. Negative 5 times positive 5 is negative 25. Now, notice that this positive 5x and negative 5x, they will cancel each other out. So we get x squared. These cancel, make a 0, and negative 25. So that's how you can see that it's going to work. It's going to work just like that each time. The bottom one here is it's a general example of what we're doing. We always have x plus something, x minus something, and then whatever this value is, we take the square root of that value. So a there is just some value, a square number like this. Now, let's suppose that a were not a square number. We could still do this. It just wouldn't be a whole number. Okay? Questions on difference of squares? All right. Factored form. So we're going to go right into the different forms of quadratics here. And we have about 15 minutes left in class, so we're going to have to work pretty quickly. In all of these forms, there will be an a. And the a is called the leading coefficient. The a tells us if the graph opens up, it will open up when a is positive. If the graph opens down, these are all parabolas, remember, because they're quadratics. It will open down when a is negative. Now, the exact value of a will tell us whether it is compressed or stretched. If the value is between -1 and +1, it will be vertically compressed. So that means it'll be squished down one way or the other. If the a is either less than -1 or bigger than +1, it will be vertically compressed. So it'll be, or stretched, stretched that way. And it's going to be one of those directions. In factored form, the P and the Q are the they're the roots of the function and the x-intercepts of the graph. Roots of the function means that when you plug P in here and there, the result will be 0. If you plug Q in here and there, the result of the function will be 0. And graphically, that means that the y value is 0. So those are the x-intercepts. Questions on factored form? Okay. In factored form here, we can see that the a value here is -0.5. That tells me that it is going to be upside down because it's negative, and it will be compressed because a is between -1 and 0. If a is 1, it's neither compressed nor stretched. So this tells me that one of my x-intercepts is -3, 0. Now you may be wondering, why -3? Well, because it's x minus p. So the only way that we can get a positive 3 is if we have subtract negative 3. So that makes our x-intercept the value of x negative 3. But here, this tells me that my x-intercept is 7, 0, because it's x minus q. So q must be 7. On the next part, the next one, my a value here isn't drawn in there, but it's 1. A is equal to 1. Because a is positive, we know it's going to be opened up. And it's neither compressed nor stretched because it's 1. If it were negative 1, it would also neither be stretched nor compressed, but it would be upside down. This tells me that I have an x-intercept at 2.40, and this tells me that I have an x-intercept at negative 2/3, 0. Questions on factored form? Okay. Standard form. All of this A stuff is exactly the same as in the previous situation with factored form. Notice that our A in this situation is the coefficient of x squared. C, right there, C is our y-intercept. So that means we're going to have a point 0, C. That will be the y-intercept of the graph. So in standard form, we get the leading coefficient, which tells us whether it opens up, opens down, is compressed or stretched. And we get the y-intercept. Compare that to factored form. We get the leading coefficient, which tells us whether it opens up or down when it is vertically compressed or stretched, just like in the other one. But we also get the x-intercepts instead of the y-intercept. So the different forms tell us different things about the graph. So here, an a value of 5 tells us that it's opening up and is stretched because it's bigger than 1. The c value of negative 6, because it would be plus a negative 6, tells us that we have the y-intercept 0, so x is 0 at all y-intercepts, 0, negative 6. For the next function, an a value of 0.01. It's positive, so it's opening up, but it is seriously compressed. The closer you get to 0, the more compressed the parabola will be. This tells us that we have a y-intercept at 0, 2.3. Questions about standard form? Can someone give me a thumbs up or a thumbs down? I know I'm going a little quickly here, but hopefully you guys are following. Okay. Anybody feeling thumbs down? You can send me a message and remind as well. Uma, it's a party for Uma. Awesome. Your teacher must have done a great job last year, Uma. Let's see. Am I getting any reminds? No, I don't see anything there. All right. Vertex form. Again, we have our a value. Notice that this time it's out in front of the quantity, which is squared, and inside that quantity we have x minus h. So a here is just the same as a in all of the other forms, in the other two forms. But now we have h and k. And k is the vertex of the parabola. So it doesn't matter if it opens up this way or this way. The vertex of the parabola will be h, k, and h, k. So in vertex form, you get the vertex. Well, that's good news, because if we called it something different like translucent form and we gave you the vertex, that'd be really confusing. So vertex form makes sense for the name. All right, here our a value is negative 15, which tells me that it opens down and is stretched. The further away we get from 1, the more stretched it is. Or the further we get away from negative 1, the more stretched it is. Oops. We also have then our h and our k. So in this situation, our h is 4 because it's x minus h. So that means our h has to be 4. And in the equation, it's a is equal to, or a times the quantity x minus h squared plus k. So our k here has to be negative 9. So that's our h and our k. Here, our a value is 1 when it's not in there, when there's nothing there where the a value should be, it's 1. And a value of 1 opens up and is neither stretched nor compressed. This tells me that our hk has to be negative 7 because it's x minus h. So to have a plus 7, it has to be minus a negative 7. So that means our h is negative 7. Plus k plus 3, our k value is 3. So I should, here, there's my point for negative 9. Here, there's my point, negative 7, 3. Questions on that? All right, that's it for the recording today.